So this is number 11, I believe it is. Yeah, number 11 from tonight's homework. So in this problem, we're supposed to find a few different things, and we'll talk more about that in a minute, but these are all the shapes that we're generally going to need to do that. So here I have drawn out this, and everything's kind of color-coded here. Here I've drawn out the right triangle that uses the height, the apothem here, and the slant height. And then I also have a lateral face here. So this is a lateral face. Okay, and then I have my base down here. So I draw these out separately for a very specific reason, because it makes life a little easier. So first off, they did tell us that this was a square base pyramid, or square pyramid. So if this is 6, then I also know that this side over here is 6, and I know that my base here is going to have an area of 36 square units. Okay, so you might say, oh, Mr. Cooley, they didn't ask for the base area. Well, it's pretty much important for all these points. So now this is a side here, and then you notice this is a lateral face. And all the lateral faces, the base of those triangles, lateral face is a triangle, is just the base of the, or just one of the base edges. So if this is 6, then I actually know that this piece here is just 3. Okay, and unfortunately, I don't know my slant height yet, so I'm going to have to try to figure that out somehow. Well, I do know that my height here, which is also in this diagram, though, is 4, so that's helpful. And then I got to try to figure out the other piece, and unfortunately, they don't actually give it to me. But since this is a square, and the apothem goes from the center here to the center, or the center of one of the edges to the center here, I actually know this length. It's just 3. It's halfway across. You could draw the other piece here. This is 3. The apothem is, in the case of a square, is half of one of the edges. So I know this is 3. Oh, and this is a 3, 4, 5 triangle. If you didn't recognize that, you could just use the Pythagorean Theorem. Now the nice thing about color coding all this is, since I know this is 3, 4, 5, oh, this is orange too. This is the slant height. It's just two, in two different cutouts here, basically. So if I want to find the area of this triangle, well, that's just 1/2 times the base, which the base of this whole triangle is not 3, but it's 6. In fact, I didn't actually need this in this particular problem. Okay, the base is 6 times the height, which in this case is 5. And from that, we can get the area of just one of these lateral faces is, what, 15 square units. Well, if I want to know the lateral area, that's just all of my faces. And since there are 4, there's 4 sides to my base, that means there's going to be 4 lateral faces. That means that my lateral area is just 4 times one of those lateral faces, or 60 units squared. So now I've got my lateral area. They also wanted to know the total area. Well, the total area, well, let's think of what we got here. We got 4 of these lateral faces, and that's 60 units squared. And then we have our base. Well, I found that too already. I already have my base area. It's 36 square units. Told you that would come up later. And so we get a total of 96 units squared. Last but not least, we've got the volume. Well, the volume of any pyramid is just 1/3 of the volume of a cylinder that has the same base and height. So 1/3 times the base area times the height. And then we can just fill in those values, since we already found everything that we could possibly need. And the height we found, or they told us, was 4. So our volume is just, what, 1/3 of 36 is 12 times 4, and this is units here, is going to be 48 cubic units. And that is all she wrote.